In our last video, we finished up talking about equations, expressions, terms, coefficients, variables, and constants. A lot of the vocab that we've already learned. Today in our video, we're going to talk a little bit more about some of the new vocabulary, such as the degree and the leading coefficient, and what that means. So I'm going to begin by writing an expression. Please copy this down. 4x cubed minus 5x squared plus 2x plus 7. As you know from the last video, there are 4 terms in this expression. This expression is also called a polynomial. And in this polynomial, we can have a degree and a leading coefficient. To figure out the degree, we're going to look at all the exponents. Exponents are those tiny little numbers at the very top of a variable. As you can see here, it's pretty obvious in the first term that that degree or that exponent is a 3. If you look at the second term, it's a 2. The third term, there's nothing there. So we have to decide, would that be a 0 or a 1? The answer is that it's that invisible 1, kind of like we had in our last video when we were talking about coefficients. When there's nothing there, it's a 1. And if it's a constant, we don't write it, but that would have 0 degree. So we're not even going to write it or talk about it. We're just going to erase that and look just at the exponents of the variables to determine the degree of this expression or the degree of this polynomial. When you look at these 3 numbers, 3, 2, and 1, which number is the biggest? 3. Therefore, for this example, the degree is 3 because it's the highest exponent. Now, if we go back and highlight our terms like we did yesterday in our video, we've got our first term. We have a subtraction sign. There's our second term. We have an addition sign. There's our third term. And this is our fourth term. Whichever term had the highest degree is the term we kind of zoom in on. So we're going to look just at this term, 4x to the third, and look at the coefficient, which again, from the last video, we know that the coefficient of that term is a 4. Since that 4 is the coefficient that goes with the term with the highest degree, that gets to be the leading coefficient. So the leading coefficient, I'm going to abbreviate, is 4 for this example. Let's try another one. Let's take 3x squared plus 4x to the fifth minus 7x. And let's try to figure out the degree and the leading coefficient. Now, again, you'll probably start to get the hang of this. You won't have to highlight every time, but it does help to see each term. Here's our first term. I'm going to choose another color for the second term. And finally, our third term. Now, this polynomial is not written in standard form. The reason I know that is because if I look just at the exponents, remember that's that invisible 1 right here. If I look at these exponents, they don't go in order like they did on our last example where we went 3, 2, 1, no variable. This one goes 2, 5, 1. That's not in descending order. So what we really want to do first is put them in the proper order. In other words, we really want to rewrite this 4x to the 5th. I want to take that blue term and put it first. Notice I didn't write the plus sign when I copied that because it's starting off. We don't have to say plus 4x to the 5th. We just know that it's positive. Which one would come next? Next, we're going to have our yellow term, 3x squared. Well, now I do need to put that sign there. Was this a positive or negative? It's positive because there's nothing listed there. Positive 3x squared. And then finally, our last green term comes down, negative 7x. Now when I look at these exponents, I can easily see that the highest exponent is a 5. So my degree is 5. From that exponent, I look down to see what the coefficient is. The coefficient, again, is 4. So that's an example of when the terms aren't written in order and you need to put them in the correct order before you go on. Finally, let's try one more example. We're going to try 5y take away 9, subtract 2y to the 4th, subtract 6y cubed. Again, these aren't listed in order because my exponents aren't going in decreasing order. So I'm going to look at my terms. I've got the first term, the second term, the third term, and the fourth term. Which one comes first? When we put them in descending order in standard form, we're going to have our green term first because that has the 4. So negative 2y to the 4th. Then we'll take our pinkish purple term, negative 6y to the 3rd. Then our yellow term, because that at least has one y in it, 5y, has to have a symbol. Remember, every term has to have a symbol starting the term, unless it's the first term. So here, that would be a positive. And finally, the blue term, negative 9. Notice I'm keeping the sign with the number as I rewrite it. So the degree is going to be 4, and the leading coefficient is going to be negative 2, because this negative sign stays with the 2 when we look at the term. Again, as you practice these, you probably won't even need to rewrite them in order. You'll be able to just look and see that that 4 is the biggest exponent, and you'll look at the number that's right there with that term. That coefficient on the term is a negative 2, and be able to spot it easily. The last thing I want to talk about are some of our properties. We have several new properties that you may have heard of, and you may find confusing: distributive property, commutative property, associative property, and the identity property. They can be confusing, but hopefully I'm going to teach you some tricks. You might think they're a little bit cheesy, but a few tricks that might help you remember these properties, because I'm sure you've seen them before in years past. The first property is our distributive property. That's where we have parentheses and a number right outside the parentheses or variable that's going to multiply by everything inside the parentheses. For instance, on this last example, it's 5 times 3 plus 5 times 4. And that's what's written here, 5 times 3 plus 5 times 4. In fact, I would probably rewrite that 5.3 plus 5.4 Once you're in algebra like we are, it's kind of confusing to have x's for multiplication. We usually prefer to use the dot so we don't mistake it for a variable. If we look at the commutative property, this is where I'll use the example that you started out today at home and you went to school, and at the end of the day, you're at school and you go home. When you go from home to school, or when your parents go from home to work, that's called their commute. You might say that you commute from home to school. Commute. It's kind of part of the commutative property word, commute. So think of that when you're looking at this, that you're going from A to B, then B to A, from 2 to 4, and 4 to 2. That's showing the commutative property. Same thing happens with multiplication. There's an example. The one that gets mixed up with commutative property is the associative property. And when I look at associative, I see the word socialize. Well, not the whole word socialize, but a lot of it. Socialize. What does it mean to socialize? It means to visit and chat. And when I look at these expressions and equations on the right side, I pretend that each one of these variables is like a little person. So we're at a party. B and C are grouped together here. They're socializing together. On the other side, A and B are grouped together and they're socializing. So whenever the grouping changes like that, I pretend, like I said, that they're at a party and they're changing who they're talking to at the party. Maybe A was at the restroom and now A's back and C goes over to get something to drink. They change who they're grouped with talking to. Here, 3 and 4 are grouped together. 1 and 3 are grouped together. So they're changing who they're socializing with. That's how I remember associative property. That might work for you, it might not. Hopefully I'm just giving you a few hints to help you remember because these questions pop up over and over and can be very tricky. Identity, A, when you add 0, or 4 when you add 0, nothing changes. Nothing can change that variable or that number's identity. When we multiply, 1 is the number we use for the multiplicative identity. So hopefully some of those little tips and tricks can help you remember these common properties that are going to appear over and over and over as we go through math for the next 4 years.